a little reminder of how you graph things. So linear, quadratic, we could see absolute value, all of those. Absolute value is just two linears put together. Okay, so the parent function, f of x equals x, or y equals, same as y equals. So goes through 0, 0, slope of 0, I'm sorry, y-intercept of 0, slope of 1. So up 1, over 1. Or down and left. So there is your f of x function. Okay, just goes down 1 and over 1. If we have negative 2x plus 1, okay, the y-intercept is 1. So up at 1, the slope is negative 2. So we can go up 2 and left, up 2 and left 1, up 2 and left 1, or we can go down 2 and right 1, down and right, because either one of those, up is positive, left is negative, down is negative, right is positive. Or we can just have h of x equals 3, which is just the horizontal line at 3. So we have those three graphs right there. So lines. Then we have parabolas. The parent function, x squared. If you don't know your pattern of the parent function, then plug values in. Okay, so you start at 0, 0. You can go over 1 and up 1, over 2, up 4. And why did I do go to up 2 and over 4? Because if I plug in 2, I get 4. 2 squared is 4. If I plug in negative 2, I get 4. If I plug in 3, I get 9. So just a little bit off the graph right here. If I plug in 4 or negative 4, I get 16. 5 or negative 5, I get 25, and so forth, because you have these points that reflect over the axis of symmetry. So that's your parent function. Now remember, it can move left or right. So typically, if we expect you to write an equation of a polynomial quadratic that is not have a center of 0, 0, you could use the vertex form. Vertex form is y equals a times x minus h squared plus k. Now, you might not always be given it in vertex form. Like letter g of x is vertex form. That's just h is 0 and a is 1. This is not in vertex form, so that one we just might have to plug in some points to figure out what it is. But x squared plus 1 is just this graph. Everything's moved up 1. So up 1, all those points are moved up 1. It's the exact same graph, just moved up 1. Okay? If this was minus 6, that graph would be moved down 6. If that was g of x equals x plus 1 squared like that, that graph would have been moved left 1, because inside is the opposite because of that minus. All right, and then that last one right there, you could complete the square. You could find the vertex, negative b over 2a. That's what I would do first, find the vertex. The vertex is x equals negative b, so plus 4 over 2 times a. So 4 over 2, that means our x value is 2. And then to find our y value, 2 squared is 4, minus 8 minus 5. So negative 4 minus 5, we get negative 9. So 2, negative 9. There's your vertex. And again, if you know, since a is 1 here, a is 1 here. If you know your pattern and a is 1, you can go over 1, up 1, over 2, up 4, over 3, up 9. I just plugged in 2 to figure out what's the y value when x equals 2 to find my vertex. And you don't have to find your vertex. You can just plot all the points that fit on the graph. If we plugged in a 1, we should get an 8. So 1 minus 4 minus 5, we get our negative 8. So when I plug in 1, I get negative 8. The same thing would happen because points are symmetrical about the axis of symmetry. If I plug in 3, 9 minus 12, 9 minus 12, negative 3, minus 5, negative 8. So we get that point. And again, that pattern happens. Over 1, up 1, over 1, up 1. Over 2, up 1, 2, 3, 4. And it's symmetrical point right here. So there is that graph right there. So again, just a reminder of graphing lines and parabolas. Something you've been doing for a long time. Lines you've been graphing since 7th, 8th grade. Parabolas since probably 9th grade. So that's what this section is evaluating from a graph and then writing those equations and coming up with an equation from a graph. So this first one, this is the opposite. Yesterday we gave you the equation we evaluated. Now we're going to give you the graph and you evaluate. So g of negative 1. All that means is x is negative 1. What is y? That's what we're looking for. So we go to the graph. Here's where x is negative 1. The y value is 0, so g of negative 1 equals 0. We do the same thing at 0. X is equal to 0. What is y equal to? That value right there, 1. G of 3. We go over to 3. 1, 2, 3. We look at what does the graph equal. It equals 2. G of 1. So we go over to 1. Here's x equals 1. What does y equal when x equals 1? 0. So you're just pulling it off the graph. Here's the graph. What does it equal? Now, yes?
Does it equal 0 because the lines?
Well, yes, because this does not. So yes, when I'm looking at 1, that's not a value.
Right.
It's all the way up to 1, so 1.1, 1.01. But this is where it equals. And it will never equal both of them, because if it equals both of them, then this is not a true statement. It tells you this is a function. So if it says this is a function, it will be a function. If it says, is it a function, that's different. All right, and then the domain. So the domain are the x values. So our x values, we go left to right. So our leftmost point, 1, 2, 3, 4, negative 4. And that is in a bracket. So negative 4. And then we're looking for all the x values. Negative 3, negative 2. Now, at negative 1, something crazy happens right here. But this covered everything up to negative 1. Negative 1 is accounted for right here. So as far as x values go, there's no break in values. So 1 is okay, 0. Same thing at 1. 1 is okay to 4. So your domain is negative 4 to 4. Those breaks that happen up and down have nothing to do with left and right. And that break from negative 1 to 1 up high was accounted for down low. Range is up and down. So our low value is 0. And then notice it goes up to 1 and then it stops. And then it jumps up to the number 2. So in union with, even though the graph does not equal 2 right here, it doesn't matter. Left and right doesn't matter. We're talking about up and down. 2 is a part of this graph. We just found a value to be 2. And range is the y value. And the way you represent one value on the range is the number with brackets around that number by itself. Don't write 2, comma 2. It's not a simplified version of that. It's just a 2 with the brackets. So yesterday, evaluating from a function, we have to pick which function it is. Like today, if we were to write this, this would have been a piece. This would have been a piece between negative 1 and 1. This would have been a piece between 1 and 4. So you would have had 3 pieces, and you would have evaluated at the correct piece. All right, so now we are graphing. We're graphing parabolas and lines. Okay, parabolas and lines. Maybe an absolute value could be thrown in there, which is just 2 lines put together. All right, so we are graphing x squared minus 1, but only when x is greater than or equal to 2. So again, if you know what your parabola looks like, you can plot those points. If not, come over here and make a table of values. Now, I'm going to start at 2. X is greater than or equal to 2. I don't want to pick decimals. I'm just going to pick nice whole numbers. So 2, 3, 4. Maybe they all fit. Maybe they don't. We'll just plug them in C. If you know what it looks like and you can just plug those in your head and plot them, that's fine. This is if you don't know how to graph. Make yourself a t-chart. So 2 squared minus 1. 4 minus 1 is 3. 9 minus 1, 8. 16 minus 1, 15. So obviously that last one or anything bigger wouldn't fit on this graph. So 2, 3. We plot that point. It's a dot because it is equal to, it's greater than or equal to, so it's not an open circle, it's an actual dot. And then 3, 8. And then 4, 16, somewhere up there. So this is going to be part of a parabola. If we were to draw that whole parabola, it would come down here and look like this. That's the entire parabola. But we don't want to graph the whole parabola. We want to graph a piece. And that piece is the piece x is greater than or equal to 2. Now we're going to graph a line. But we're only going to graph a line between those two. That does not mean we graph the line at 1. 1 is not the only number that happens between 0 and 2. Okay? 0.1 happens, 0.2 happens, 0.3 happens, 1.7 happens, 1.8 happens, 1.9, 1.99999. So when you're plotting these points, you have to start at each end, but you just might not include those, and you'd have circles. Or make yourself a t-chart, 0, 1, and 2. When I plug in 0, I get 1. 1 plus 1 is 2. 2 plus 2 is 3. All right, so 0, 1. Here's 0, 1. Now it says x is just greater than 0, so 0 can't be included. So right there, I have to make that an open dot. It still has to be part of the graph, but it's just going to be an open dot because I have to go right up to it. I can't just start at 1. I have to go between 0 and 1. I can't just pick where to start. I start at 0, but it's an open dot. And then at 1 it's 2, at 2 it's 3. Now that's an open dot, but we already have a closed dot there, so we're not ever going to put an open dot. Never will you put a closed dot and an open dot. That means you don't know what you're doing. Okay? No. No open dot over closed dot. Is it open? Is it closed? I don't know. Okay? If I did that, you wouldn't know either. It's already part of the graph. As long as it's part of one and not the other, it's still a function. And then I just connect those dots because that is a line. So I have a line and a parabola there. Now these questions say list the domain and range. All right, so our domain for this are going to be the x values. So we look left. The leftmost point is 0. And that's with a parenthesis because we go right up to 0 but don't include it. We cannot start at 1. We can't say 0.1 because then there's 0.01, then 0.001, 0.001, and you could do that forever. And then it goes to the right forever, so to infinity. And then the range is up and down, so low is 1, again not included. It goes up forever to infinity. Is it continuous or discontinuous? If I said I want you to take this picture and draw it somewhere else, if you could take that picture and redraw it without picking up your pen or pencil, which we could do, that's going to make it continuous. That's just as much as you need to know about continuous or discontinuous for now. If you can redraw it without picking up your pen or pencil. If it's discontinuous, it's not, so we'll talk about that when that happens. All right, now we have 3 different graphs to draw. So we're going to start with the line right here. We're only going to graph the line when x is less than 0. But again, we start at 0. Less than 0 doesn't mean we start at -1. Less than 0 means we start at 0, -0.9, -0.8, -0.1, -0.2, all of those numbers. So 0, -1, -2. Once again, the t-chart's not necessary. If you can draw it without the t-chart, terrific. So I get -1, -2, -3, -4, -5, and so forth. So when I plot 0, -1, because it says x is less than and not equal to, that's going to be an open dot right there. Okay, it's going to be open. And then I plot -1, -2. Basically what I'm doing, hopefully I recognize the slope is 1. So down 1 over 1, down 1 over 1. Once I have the y-intercept, and we must have an arrow because it says x is less than 0. It doesn't have an endpoint. So I have to show everything less than 0, and that arrow does that. Now I have this. So really with this, the best thing to do is make a t-chart either on the table or in your head, on the paper in your head, it's up to you, and use all those numbers that are given. You can use decimals. I would not use decimals. I would just use the nice whole numbers or integers that are in between. So I would go from 0, 1, 2, and 3. X is less than equal to -3. X is greater than or equal to 0. X is physically in between 0 and 3. So between 0 and 3. But you have to include the 0 and the 3, because if you just do 1 and 2, you're forgetting about all those numbers between 1 and 0 and all the numbers between 2 and 3. So if I plug in 0, I get -3. If I plug in 1, I get 1 minus 2 minus 3, which is -4. I plug in 2, I get 4 minus 3. If you can do this in your head, that's fine. I'm just writing it down so you see where these numbers come from. If you can't do that in your head and plot them as you go, write it down. 9 minus 6 minus 3, 0. We know that's a parabola. We should know that's a parabola. So 0, -3, it's a closed dot because it's equal to 1, -4, 2, -3, 3, 0 is also included. The vertex on this one is included because you can see the shape went from -3 down to -4 and then back up. So there's that piece of it. And then the last piece of it, y is equal to 0. Horizontal line if x is greater than 3. So we go to 3. Hey, we don't start at 4. We start at 3. It's already closed dot, so we don't have to worry about it. This couldn't ever be. You can't ever have two numbers that have an equal sign or it's not a function. And this is a function. It tells you graph the function, so it will be a function. If your graph is not a function, does not pass the vertical line test, you've done something wrong. So just from right here, and we draw the arrow. So that is the graph of that piecewise. Those three pieces put together make a function. If you graph something and it is not a function, let's say you take this one and you graph that right there. You do that. Well, it does not pass the vertical line test, so you have done something wrong. You did not follow the restriction that was given. If it says this is a function, it will be a function. So your graph should show that. All right, so our domain are the x values. This x goes left forever, so we're starting at -infinity. As we move to the right, there's this thing right here, but 0 is not included, but is, so we're good. To infinity, so -infinity to infinity. Then the range. This goes right here, but that arrow overtakes it, goes down forever. So that'd be -infinity. And then as we're moving up, we have all these points, we have all these points, and we have this hole right here, -1, but -1's okay over here. So as long as it's somewhere, it's still a part of the range. So we go all the way up to 0. 0 is the highest it goes, and it is part of the graph, so it's a bracket. Yep.
Why do you, can a line never be like open?
Never be open.
Like the circles are like, if like a line can't be like an open like 1 or something.
I don't know what that means.
Okay, never mind.
A line open of,
Like, never mind. Dumb question.
Like, are you saying could there be an open circle on a line?
Yeah.
Yeah, right there is.
Okay.
Right? And this one, we had that too.
Right.
So yes, it just depends on the problem. This turns to equals. That turns to closed. It all depends. You can't say this will always happen, this will always happen. It just depends what the problem tells you. Every problem will dictate that. All right, then we have continuous or discontinuous. Could I draw this without picking up my pencil somewhere else? I couldn't. Draw this, jump down here, draw it. So this one would be considered discontinuous. And because this is not just a point that's discontinuous, this is a jump. So that is considered a jump discontinuity. A point discontinuity is if you had a line, a missing point, like that. Okay? That is a point discontinuity. This is a jump. So those are the two types of discontinuity you can have. Again, a parabola and a line. So this parabola, if we know what that looks like, and we can graph our parabola, we know what the vertex, this is the parent function down 8. So let's do it that way instead of making a t-chart. The parent function down 8. Then if I follow my pattern, over 1, up 1, over 1, up 1. Because if I plugged in 1 squared minus 8 is negative 7. Negative 1 squared minus 8 is negative 7. If I go over 2, that's up 4. 1, 2, 3, 4. Over 2, up 1, 2, 3, 4. I'm following this still. I only graph where x is less than 3. This next one is 3. Over 3, up 9. So now that's an open circle because we can't include 3. We have to include everything between 2 and 3, but not 3. Over here, we're still good. And then, so all of this is that graph less than 3. So we have a lot more of that parabola showing. How do we know how much of the parabola shows? Well, we don't. We just follow the restriction. Okay, this is the restriction. We have to follow that. That's the part of the graph that we graph, whatever it tells us to. If the t-chart makes more sense to you, do the t-chart. All right, then the line. Negative x plus 4. We don't want to make a t-chart. We want to go up to 4. So 1, 2, 3, 4. Here is the y-intercept. But we only want to graph where x is greater than or equal to 3. So we have to move along that line. Down 1 over 1, down 1 over 1, down 1 over 1. It says greater than or equal to. So now that becomes part of the graph. Down 1 over 1, down 1 over 1. And we can graph it that way. However it works. If you're really good at graphing, do what I just did. If you're not so good at graphing, make a t-chart. Does it, so if you just looked at that, is that an open circle with a closed circle? Nope, it's just a closed circle. You can't do this. So now there's a closed dot and an open circle right there. It was open for this graph, but then this graph closed it up, so that's okay. One of them can close it up or neither of them, but they can't both close it up because then the x's repeat and it's not a function.
Would it be considered a function if you had two open circles?
Because then all that would happen is this. Does that make it not pass the vertical line test?
No.
Nope. It just makes it have a point of discontinuity. All right, so domain. Domain are the x values. This goes left forever. So that's negative infinity. All the x values are accounted for. To the right forever, infinity. The range, up and down forever. Even though it looks like this is where it stops, this is a low point, This arrow overtakes that low point, so that would be also negative infinity to infinity. And then if I wanted to redraw that same picture somewhere, I could redraw that without picking up my pencil. So continuous. So two different ways. If you're very good, just plot the points at the restrictions given. If you're not so good at graphing, pick the points, use a table of values, pick them and go from there. All right, now how do we show this algebraically? So if it's some kind of crazy graph that you can't graph, you don't want to graph, or we don't want you to graph, we say show algebraically. Really, this was continuous because this y value and this y value ended up at the same place. This was discontinuous because this y value is at -1 and this y value is at -3. So -1 and -3 did not equal each other. So algebraically, how you show that is you just pick this number. This number has to be the same. It will be the same. If it doesn't, then we're not meeting. Then we're at x equals 2 and x equals -7. There's no way for them to meet. Do they meet at the same place? So this is how you would show that work. 3 squared minus 8 equals 1. -3 plus 4 equals 1. 1 equals 1, so it is continuous. Because one graph went to 1, the other graph went to 1, they met at 1, so therefore it was continuous. Here, 2 squared minus 1 equals 3. 2 plus 2 equals 4. 1 goes to 3, 1 goes to 4, so they don't go to the same place, so that would make it discontinuous. So that's how you show it algebraically. Now, there could be 3 different parts. There could be an extra part right there. Pick the first 2. It's either yes or no. The second 2, it's yes or no. If you have 2 yeses, it's yes. If you have a yes and a no, it's a no. For example, if we did these 2 graphs, the answer would be yes. These 2 graphs do meet at the same place. But these 2 graphs do not. So this would be these sections would be a yes. This would be a no. It's all one function together, so the answer would be discontinuous if there are 3. All right, now the opposite. Now you're given the graph, and you have to write the equation. So again, you have to recognize these graphs. So if we think, well, I don't know, that kind of looks like it's a line. Up 1 over 1, up 1 over 1, not a line. Because it's up 1 over 1, and then it's up 4 over 2, so not a line. So it's a parabola. Only things we can have: parabolas, lines, and absolute value functions. Those are the only 3 that you are going to be responsible for at this time. So hopefully we recognize that that's the parent function of a parabola. Only thing that could happen is it could move left and right, up or down, for now. So f of x equals. Notation is important, but let's think about it. This test is going to have some, here's the piecewise graph it. It's going to have, here's a graph, right, the piecewise. You don't even have to know what the notation is. All you have to do is, I forgot what the notation is. Oh, let's look. Here's the notation. I know exactly how to write it. The notation is given to me right there. So f of x equals, little bracket. Doesn't matter if you do the line or the parabola first. I'm going to do the parabola first. So the parabola is x squared. But x squared is the entire parabola, and all we see is half of it. So we only see x squared when x is less than or equal to. You can pick whichever one you want. It has to be with one of them. Because 0 is part of the graph, you can include the 0 with the parabola or the line. It's up to you. It does not matter. We'll include it with the parabola. So there's one piece. Then we have this line. Y equals mx plus b. Slope is rise over run. Rise 4, run -3, so -4/3 x. The y-intercept 0. So -4/3 x. And we have a start and an end point. the lowest value is 0, the highest value is 3. We already included the 0 in our parabola, so we can't include it in our line. The 3 is included, so it has to have an equal sign.
If you can't include it in your equation, then why did we go back to the one where it was open and then we closed it?
Because if you notice, it was included here, it was not included there. So when we graphed our parabola, we left it open because we did that first. And then when we graphed our line, it closed it up. If we would have graphed our line first, then it would have already been there. But notice all of them that match up right there, they're never going to both be equals. They could both be not equals, but they can't both be equals or it's not a function. Okay. All right, now we have two lines. Again, y equals mx plus b. Hopefully we don't need y equals mx plus b over here. We just see that that's y equals 1. Couple different ways to get it into slope-intercept form, point-slope form. We can go from point-slope form, or we can just use slope-intercept form. It's up to you, whichever way you like. I'm going to use slope-intercept form the whole time. So easy to get the slope. Rise over run. So y equals 2/5 x plus, let's say that's 0.2. No, we can't just make up what we think it is. Hey, it has to be very exact, exactly what it is. So again, you can use point slope or you can use slope intercept because we have this point that we know is a point on the line and we have this point. We don't know exactly that's -2 something, -1 something, 0 something. That's the whole point why we can't just figure out what the y-intercept is. 1 something. I don't know what any of those points are, but I do know that because it shows me that's a point on the line. And I do know that. This line's made up of millions of little points. I just don't know what they are. So I'm going to pick this point right here. That's the point -3, -1, which is an x and a y. So I'm going to plug that in. -1 equals 2/5 times -3 plus b. Make sure your b doesn't turn into a 6. Mine's kind of looking like a 6. So -1 equals -6/5 plus b. Add 6/5 to both sides. And 1/5 equals b. So now I have my slope, I have my y-intercept, so I can write an equation for that line. So f of x equals 2/5 x plus 1/5. When x is less than, we'll go ahead and put the equal sign here so don't forget it, 2. And f of x equals 1 when x is greater than 2. If you wanted the equal with the greater than instead of the less than, that's fine. It doesn't matter which one it's with. Okay, you can put it with either one that you want. Either one is okay.